Good morning. We can talk about geometry this morning because all of my seniors are at their big buddy, little buddy breakfast. So if you look, the key to the lesson that we have for today and tomorrow in section 1-5 deals with the definitions. You need to make sure you understand the definitions of the particular types of angles. So we'll go to the whiteboard here, and I will show you examples of each one of these so that you know what they're talking about. Now, the first type of angles we talked about are adjacent angles. And adjacent angles have a common side. So if I have a situation like this, and then I have a second line like this, and then I have a third line coming down like this. And if we label these points, so let's say this is point A, this is A up here, this would be B here, and this would be C here, and we'll let the vertex up here be D. So now I can talk about angle, I'll come back over here and do this. I can talk about angle ADB, and I can talk about angle ADB is adjacent to angle BDC. I put my angle symbols in here. So angle ADB is adjacent to angle BDC because they have this common side. This common side that goes right down through here, okay? So adjacent angles will have the same vertex, and they will have a common side. So you can have something that looks like that, or you can have something, if we go back and look at a different situation, you could say that angle ADC is to angle BDC. So we come back, angle ADC is adjacent to angle BDC because now they have a common side, which is right along here, okay? So you either have two angles that are side by side, or you have a smaller angle included in a larger angle. But when you talk about adjacent, the two angles have to have a common side, so they can't be separated from each other. They have the same vertex and a common side. Okay, now, when we talk about the next thing we're going to talk about, so we will erase all of this. So we'll erase all of this. And so now we're going to talk about a linear pair. And a linear pair is two angles that form a line. Okay, like here's my line. If I have a second angle coming right up here, and now we can talk about this point right here being point A. This will be A. This right here would be B. This would be C. And this would be D. Okay, now we can come over here and say that ABC, angle ABC, and angle CBD form a linear pair. And the reason for that, reason why that is because if you'll notice, say when you put those two angles together, the measure of this angle here plus the measure of this angle here equals 180 degrees, which makes ABD collinear, and that makes this a line. So when you have a linear pair, you have two equations or two angles that will combine together to create a line. Now, the next thing we're looking at are vertical angles. So here I'll erase this over here, and I'll erase this down here. And then I can come in and add one thing to this. If I take this segment CB here and extend it back like this so that I have another point, which is, let's call this down here, point E. Vertical angles are created by two lines intersecting. So you see we have line AD and line CE intersecting at B. So they form, let's see if we can erase this right here, okay, and erase that. Now, let me go back. So when you have two lines intersecting, you form two pair of angles that are the same size. Angle CBD and angle ABE are equal. They are vertical angles. I always just say you cross your hands and you create two pair of vertical angles. Angle ABC here, which is this angle, is congruent to angle DBE, which is this angle. So when you talk about vertical angles, you know that they are equal. But once again, vertical angles, when you see the word or when you hear the word vertical angles, you need to know exactly what that means. Okay? Now, the last two things we're looking at are, I'll get rid of this. We're looking at complementary and supplementary angles. So, complementary and supplementary. Now, when you look at complementary and supplementary angles here, so let's draw ourselves a picture. We will draw this line across here. I'm going to draw a second line here, which is perpendicular. Remember, perpendicular means that these two angles form a right angle down here, and we indicate that with this little square box down here. We'll do it like this. We indicate it with a square box which comes across like this and goes, whoops, gotta do that, and goes down like this. So when you see that little square box there, you know that, let's say in this case, this is A, so here we have A, this will be B, and this will be C, and then we can put a D up here. So you know that DB, segment DB, line DB, we just make it a segment. Remember, if I make it a segment, it's got a single line across the top with no arrows. Okay, is perpendicular, and the way we write perpendicular, if we just do it like this, the symbol for perpendicular look like this. It's a little line like this. It's basically an upside down T. So this is perpendicular. When you see that, we say that DB is perpendicular to AC. That means that angle ABC are the measure of angle ABD is equal to 90 degrees. And that also means that angle CBD is 90 degrees. Now, these two angles, ABD and CBD, would be supplementary because they add to 180. So supplementary here means you add to 180. Okay, you don't have to be adjacent. These two angles are adjacent because they have a common side, but you don't have to be adjacent to be supplementary. All you have to do is add to 180. Now, complementary angles, if we come in here and add one more line to this, like if we come out here and say, okay, we're going to have this will be point E. So this will be point E. Now, so now we have this angle here. So we have, if we look, we can say we have angle CBE plus EBD equals 90 degrees. Okay, so if I can finish this up. So the measure of angle CBE plus the measure of angle EBD equals 90 degrees. So when you have complementary angles, once again, they add to 90, and it doesn't matter. They don't have, in this case, CBE and EBD are adjacent, but they don't have to be. All you have to have is two angles that add to 90 degrees, and that means they're complementary. Now, the way I remember this, C comes before S, and 90 comes before 180. So complementary goes with 90, and supplementary goes with 180. Okay. Now, so let's look finally here at a problem. So we'll erase all of this. Now I'm going to put a picture up here of a problem. It's in your book. So you have a line like this. You have a second, or a segment rather, you have a second segment that looks like this. And then you have a third segment that comes down like this. Okay. Now, so this is D up here. That's D. Over here we have Q. Down here we have R. In the middle here we have T. And this is W. And this up here is S. So this is S. Now, so these are the points on my picture. So I have this is D, this is Q, T is the intersection, R is down here, W is here, and S is here. Okay. Now what it tells us in this situation, it tells us that W here is 5x plus 6. So right in here, W, or it tells us that WTR is 5x plus 6. Okay, that's the measure of that angle right there, right? Now, and it comes in here and tells us that this angle right here is 2x. So we put a 2x in there. That's that angle. And then this angle up here is 4y minus 2. Okay, now then. So what it wants us to do, it wants us to find x and y. So we'll write that out here. Find x and y such that PR is perpendicular to, no, wait a minute. PR, I got to put P up there. That should be DR. DR is perpendicular to SQ. Okay, so this is going to be segment DR, segment SQ, and we're perpendicular. So we got to put our little perpendicular right in here. Now, so if we look at what's going to happen here, remember perpendicular means that QTD has got to be 90. So the first equation here, we can come in here with this to find y here. We can say 4y minus 2 is equal to 90 because that's what has to happen in order for SQ and DR to be perpendicular. So if we add here, we just get 4y equals 92, and we divide 92 by 4, so we get y equals, so half of 92 is 46, so half of 46 is 23, so 23. So y is 23. Now, to get x, if you look down here, see RTS, this whole angle across here, from here all the way across, well, let's come down here. From here all the way across to here has got to be 90. And that 90-degree angle is made up of angle RTW and WTS. So now we have an equation that says 5x plus 6, which is that angle, plus 2x is equal to 90. So we do our algebra, we get 7x equals 90 minus 6, which is 84. And then we get 7x, let's see, 7 goes into, so if we divide 84 by 7, we get 12. So x would be 12. Now that's the type of problem that you're going to be looking at in your homework. The first thing you will get a picture, get out of this, you will get a picture and it asks you to just name different types of angles, like the ones adjacent angles and linear period, vertical angles. So you just look at the definition and you find there are several different answers, not necessarily one single answer for those types of problems. But then when you get to the other situation, you set up your equation based on the definition of the type of angle you're working with. Okay, so if you have any questions, give me a holler, send me an email, and I'll get back to you. Have a good day.